turned in. But some of you also need to make sure that you get the online turned in today too. Okay, 5.5 online, so don't forget about that. Okay, make sense to everybody? All right, 5.6, last section in chapter 5. Binomial distributions. You ever heard of this word binomial before? What's it mean?
One nomial. Two nomial.
Two nomial. Okay. Like Romeo and Juliet, right?
This is just a sad story.
It's funny because
You guys don't like this triangle thing? Do you guys know Pascal's triangle?
No.
You don't know this?
No.
Okay then, that's concerning. But that's okay.
Guys,
I don't know what.
All right. How about this? Do you know binomial expansion, like x plus 2? If I had to take this to the second power, would you know how to do that?
Yes.
yeah.
Okay, so those are binomials up there. If I had to have you multiply two binomials, you could do that. Now, binomial in terms of distributions is going to be a little bit different when we start talking probabilities. Okay, so as 5.6 is titled Binomial Distributions, the question we're trying to answer for me, Michael.
How can you determine the frequency of each outcome of an event?
Okay, how often is something going to happen? What we're going to start doing today is kind of like what we talked about prior to starting this right here. Say there's a 70% chance it snows or there's a 95% chance it snows. We really want to know what's the possibility that it's going to happen. Okay, and we're going to talk about how changing that 70% to 95%, what effects that has today. So, goal is to answer the question, how can you determine the frequency of each outcome of an event? We have to be able to, first of all, construct and interpret probability distributions. And then we're going to construct and interpret binomial distributions. I'll show you what that means, okay? A lot of terms in here. It's not going to make a ton of sense right off the bat. I think as we go through the examples, the terminology will make more sense as we go through the examples. First one to read random variable for me.
A random variable is a variable whose value is determined by the outcomes of a probability experiment.
Okay, so it's determined by the what?
Variable.
Determined by the outcomes of a probability experiment, okay? Next one's called a probability distribution. And again, we'll look at these in examples, so there's not going to be a lot to write over there on those empty boxes. It's going to be a probability distribution is a function that gives the probability of each what? Possible value of the random variable. The sum of all probabilities must equal what? 1. So we're going to talk about events today, and we're going to say, oh, what's the probability of this happens? What's the probability of this happens? What's the probability of this happens? Once you've accounted for all the events in terms of the probabilities you're talking about, all of those probabilities should total to what value? 1. Okay? Binomial distribution. This is really what we're after today. A binomial distribution shows the probabilities of the what? Outcomes of a binomial experiment. When I talk binomial experiment, I'm talking about what's the percent that something happens and what's the percent that it won't happen. Okay? Binomial experiment says to do what, kids? We'll talk about that here. Histogram, kids. You guys know what a histogram is? It's just a bar graph, but instead of showing bar graphs by labels, we show bar graphs in ranges or intervals, if you will. Okay? So it's a bar graph shown in intervals. All right? Let's look at this. Oh, I love this stuff. I think that this is so cool. Okay? I'm going to draw a chart over here on the left. It says the spinner is divided into what, kids?
3 equal parts.
It says let x be a random what? That represents the sum when the spinner is spun twice. Okay. Now, I need to change the numbers on here. I don't like the numbers that I have up here. We've got a nice spinner, but we're going to change the numbers. Change this 3 to a 0 in there. Okay? All right. Never mind the colors, but how many times are you spinning that spinner up there?
Twice.
Now we're going to take the sum of our two spins. Kids, what's the lowest sum I could end up with?
0.
Why 0?
You could roll. You could use 0 twice.
You could land on 0 twice. All right? But what would be the highest sum I could come up with?
4.
Okay, so the table that I have down there, the the table that I have down there says the sum can either be 0 after 2 spins. The sum could be 1 after 2 spins. The sum could be 2 after 2 spins. It could be
3.
or it could be what? 4. What do you think the hardest sum to get is? 4. What do you think? Okay.
Wait.
4 is impossible.
0.
Let's check this out. How many spins do we get? 2 spins. So let's talk about this, kids. On the first spin, I'm going to draw a diagram over here. My first spin. Okay, help me out, kids. On that first spin, what are my possible outcomes?
0, 1, 2.
0, 1, and 2. Okay? So let's say I spin a 0. Then we've got a what? A second spin. Well, guys, off of spinning a 0, what are your options on the second spin? A 0, a 1, or a what? Okay. Or maybe on that first spin, I spun a 1. After that spin of 1, what are my options for the second spin again?
0, 1, 2.
Maybe I spun a 2 on the first spin. What are my options on the second spin? Now I have a question here, kids. The final column over here is always the number of outcomes, but how many possible outcomes are there for us when we spin twice? Well, how many outcomes do you have on the first spin? 3. And how many outcomes do you have on the second spin?
3.
So what's 3 times 3? So do you guys all agree that there's going to be 9 possible outcomes here? Okay, let's talk about this real quickly. Okay, it says make a table and then do what?
Draw a histogram showing the probability distribution for X.
Okay, kids, how many possible ways from the first spin and the second spin will the sum of the two values that you land on total up to 0? How many ways out of the 9 possible ways will that happen?
1 way.
There's only one way. You get 0 the first time and what?
1 to 0.
Okay, you know what I'm going to do? Here's what I'm going to do.
What are you?
I'm going to go to this chart over here that we've got. If I follow the branches, 0 plus 0 is what in the end? If I go 0 plus 1, what's that in the end? If I go 0 plus 2, what is that in the end for a sum? Okay, how about this sum right here? What about this one? What about this one? What about this one? You sound so enthused! I love it! Okay. Oh my gosh, I just dropped that pen.
Careful.
I meant to do it.
Okay.
Okay. It's all part of the master plan. Ooh, but don't spill the coffee on the sweater. Oh, Allie wants me to change out of blue.
That's a nice sweater.
Thank you. I love it because it's got a gator on it. It's an alligator. I brought my pet to school day. Bring your pet to school day. Gator bait.
That's a
Are you
nice.
sure you're just like not a secret fan of Florida?
I am not either. I don't. No, don't.
That looks like they're low.
Don't you dare say that, okay? I would pull for Iowa State before I would pull for Florida.
Because they're Florida
Okay.
Gators.
Okay? All right. Here we go. Kids, how many possible ways was the outcome of sum of 0 in the 9 possible outcomes? Once. So the question becomes this. The number of outcomes that were 0 was 1. Okay. How many outcomes became a 1? How many times does 1 show up here as a sum?
1, 2.
2. How many times did 2 show up as a sum?
I'm at 3.
Okay, let's just check. There's a 2 is here, 1. You guys agree 3?
Yeah.
Okay. How many 3s showed up there?
2.
And then what else?
2, 3, 2, 1.
Okay.
It's like it rises and then it goes back down.
Yeah, so here's the deal. When we talk about the probability, what is the probability that our sum was what? Well, the probability that the sum was 0 was what out of what, kids? Wouldn't that have been 1/9? Agree with that? Okay. What's the probability that the sum of the 2 spins got us a 2? 2/9. Next one would be what?
3 9.
3/9, or some of you might simplify that to 1/3. What's the probability that the sum was 3?
2 nines.
What's the probability that the sum was 4? Guys, if I was playing a game right here and I wanted to make sure I had the best chance of winning, what sum would you really want to go after? Why 2? Because that happens most frequently, right? Okay. Now, guys, are the sums of values after spinning twice, is the probability of each outcome the same? No. Probability of a sum of 0 is very different than the probability of a sum of 2. Okay? But this is going to be some kind of a binomial distribution because let's think about this. Take all those p of x values in the bottom, 1/9, 2/9, all the way up. Add them up for me. Tell me what you get.
Probably 9 nines. Yep.
Does it get 9/9?
Because it's the 100%.
So the probability of all of those events add up to what? 1. Okay, so this is what a binomial distribution is going to look like. The binomial distribution, if we talk about binomial distribution, it's relevant to first event, then what? Second event. Okay? So if I was to make a histogram of this, I'm just going to sketch this real quickly, and you can do the same thing. Okay, I'm just going to go ahead and make like this. Okay? And I'm going to put down here that these are my sums. We add a sum of 0, sum of 1, sum of 2, sum of 3, sum of 4. Okay, how many times was the sum 0, kids?
Once.
Okay, so maybe over here on this chart I make a 1, I make a 2, I make a 3. So it was 0 showed up once. How many times did the sum of 1 occur, kids? 2 times. How many times did 2 occur? Okay.
Oh, that's
The 3 occurs how many times? Okay, and then the 4 only occurred what?
Once.
Okay. And that's basically what Adam did to me the other day when he sat over there and I said something about his hair.
Oh, I get it. I get it.
How long does it take you to get?
Okay.
I think the 1 and the 3 were.
It's called binomial distribution. Typically stuff in the middle is going to happen most often, but it's not always going to be the case. And we'll look at some examples like that in a little bit. But kids, this is considered a histogram for what? Probability distribution. How are the outcomes distributed, or how are the possible outcomes related? Okay. Again, if I looked at this chart, I'd say, ooh, what would you want to get? What's the best? What do you have the best probability for summing up to in 2 spins? Well, it's a 2. It happens 3 out of the 9 times. Okay. So in example 2, let's just use example 1 to interpret some things. It says down there, use the probability distribution in example 1 to answer each question. First question, kids. What is the most likely sum when spinning a 3-section spinner twice? What is the most likely sum?
2.
2. It happens how many times? A 2. It happens how many times? 3 times. Okay. What's the probability that the sum of the 2 spins is what, kids?
Odd.
Well, what were your odd sums?
1 and 3.
1 and 3. Well, how many times did 1 occur?
That'd be 2.
How many times did 3 occur? So it'd be 2 9s plus. Yep. So this is basically the probability that the sum is 1 plus the probability that the sum is 3. By the way, is 0 odd or even? Actually, by definition,
It's even.
0 is even.
Because you get.
Because 0, and then the next one's odd.
Yeah,
And the next one's
so-
even.
So the probability that the sum was odd, sum of 1, what was that probability again? 2 9s plus, probability the sum was 3 is 2 9s. What's this equal again then? 4 9s. Okay. Are you guys okay on how I set this diagram up on the first spin, second spin, a binomial experiment right here to get a binomial or a probability distribution for those 2 events?
Yes.
Okay. Now, I think that that page is pretty easy.
Yeah, it
There's going to be some really big concepts on this last page. So when you flip over to the third page after you have everything down, write down that this page is most important in terms of what we're going to talk about this section. Okay? This page, mucho importante.
In German, I don't know if that's
9.
That was Spanish.
Peppermint bark coffee.
Peppermint, you said? You just say peppermint?
Mm-hmm.
Me and Lincoln.
Next time, don't make
Stunts my growth.
So I can smell that coffee.
Is it good? Smell good? Okay.
I got you ready.
Kids, example 3, this is where I really want to get to make sure you understand this. Example 3 is a biggie and how this works, and I'm going to show you how this works, but this is mucho important. Okay? Constructing a binomial distribution according to a survey about what?
About
62%
62% of
adults
adults have what?
visited a dentist in the past
Visited a dentist in the past year. They're basically saying there's a 62% chance that you are going to the what? Dentist this year. Yes. Hurry. Okay. You asked 5 randomly. How many people are we talking about?
62%.
62% of adults, right? You asked.
5.
There's 5 people we're talking about. Selected whether they have had a dentist visit this past year. It says draw a histogram binomial distribution of your survey. I'm going to show you how this works. This is not as easy as it sounds. Okay? But here's the deal. How many people did we survey? 5. Means that there's a chance that 0 of the 5 go. Maybe 1 goes. Maybe 2 go. But if 2 go, is it the same 2 person, or could it be a combination of those 2 people? Could be a combination. Different 2 could go, right? And these 2 are very different than those 2, right? So we're talking about combinations when it relates to this. There's a chance that 3 go, but it might not be the 3 that we think. It could be any combination of what? 3. Okay, or 4 might go. But it could be any combination of what? 4 or 5 go, then it's all what? The only one that's really not a combination is the 0, the 1, and the 5. Well, here's the deal, kids. I'm going to show you how this works, and I'm going to try and make this very simple. But a binomial distribution is going to have what we have called a very nice formula to this. Okay? I'm going to set this up for the possibility that 0 people go, the possibility that 1 person of the 5 goes, that 2 go, that 3 go, that 4 go, and that all 5 go. Okay? Now, what I'm going to put up here is this. There is a 62% chance, based on the data, that a person does what? Goes to the dentist. Which means if there's a 62% chance that the randomly selected person goes to the dentist, then what's the chance that that person is not going to the dentist?
38.
That you're not going. Okay, here's how this works. Okay. We talked about here if there was like 2 or 3 or 4 people going. It could be a combination of any of those 5. It could be a combination of 2 people, or a combination of those 5 people 2 at a time. Okay? So the way this works is as follows, kids. We would consider 62%, I'm going to put an S up here by 62%, and I'm going to put an F by that. S is going to stand for the number of successes we're going to have. And F is going to stand for the number of failures you have. In this case, a success is considered going to the dentist. A failure is going to be considered not going to the dentist. Okay?
I haven't went to the dentist for.
What's that?
I haven't went to the dentist for such a long time.
No. You know what? I was supposed to go Wednesday and I missed my appointment. I totally spaced it out.
Whoa, guess what? Michael hasn't went in 6 years.
Really?
What?
Still going strong.
That's disgusting.
Yes, right. 4th grade.
You go to the one in the 4th grade.
Yeah. Did you just say don't be kissing him?
Terrible people, I tell you. What? I think I'm doing pretty good.
Yeah, I was gonna say, I thought.
Okay. You guys want your formula for each one of these? I'm going to write this down. Okay.
Is that
Anytime.
times? Is that times? That little dot?
Yeah, that little dot means times, and I should put a parenthesis around it. Okay. Anytime we talk about stuff that starts throwing percentages in there like this, that says there's a 62% chance this happens, and we're talking about a group of people, here's how you set up a binomial distribution. Okay. Your formula for any binomial distribution is a combination of n things, r at a time, times your success rate. This is like your success rate as a, well, let's see, what was our success rate here?
62.
Okay, so we would call that a success rate as a decimal. So 62% would really be what value in this case? 62. Okay, and then that power up here is to the number of successes you're talking about, okay? And then that gets taken times the number of people that are going to fail, okay? 3 people might be successfully going, which means 2 people are failing to go, okay? And we'll talk about how that works. So here's this first one right here, kids. We want to know what's the probability that of those 5 people, knowing that there's a 62% chance that each one of them goes, we want to know what's the probability that 0 of those 5 are going. So here's how this works. To know the probability that 0 of the 5 people chosen visit the dentist looks like this. You would do 5. Combination of those 5 people, how many do we want me to go? 0, okay? So we're going to do a combination, 5 things, 0 at a time. Now kids, let's talk about our successes first. First of all, what is the success rate? 62%. So as a decimal, we're going to put in what?
0.62.
Okay. Now, listen to what I said. Of the 5 people, we're saying 0 are going. So how many successes do we have? 0. So you're going to put a 0 up here. And then we got to consider the people that failed in.
38%.
So it'll be 0.38. So if there's 0 successes, how many failures are there here then?
Times 0.38.
Okay.
Oh, there's 5 failures. Wow, that's.
Okay, so here's what we're going to do. In your calculator, somebody do the combination of 5 things 0 at a time. Tell me what that number is. You get 1. Okay? There is only one way that all 5 people are not going, right? Either all 5 people, if 5 people don't go, that's everybody, right? That's just going to be one group of people, isn't it? Not all 5. The only number of combinations, if there's 5 people right here, how many people can I come up with? How many combinations of 5 can I come up with 5 people? It's the same number of people in there, just 5 of them. So it's only going to be one combination. Okay, what's anything to the 0 power?
1.
Anything to the 0 power is going to be 1. So this is really 1 times 1 times 0.38 to the 5th. So somebody run 0.38 to the 5th. And let's go, I can't remember if they want us to go 3 places when you do your assignment or 4.
It's 0.006.
Let's go 3 places on all this.
0.008.
0.008. Okay, so here's the deal, kids. I'm going to have you write down 0.008 there. I'm into my chart a little bit here, so I need to make some room. Okay, guys, if I move the decimal 2 to the right, that would be what percent? 0.8%. There's less than 1% chance that nobody's going to the dentist. Knowing that 62% of the people have visited the dentist, you choose 5 people at random, and of those 5 people, how many of them are not going to the dentist? There's a 0.8% chance. Is that pretty high or pretty low? Okay, so now what we want to start looking at, kids, is the combination of one person. Now let's think about this, kids. In this situation right here, think of 5 people. How many possible ways can I choose 5 people where just one of them is going? So if there's a group of 5 up here, how many combinations would I have for the person that's going to the dentist? 5 of them. Any of the 5 could go. So we're going to look at this as the combination of 5 people, one at a time. Somebody run that. 5 combination 1. Anybody want to guess what that equals?
5.
Check it and see. Because we just talked about if there's 5 people up there and only one's going to the dentist, one of any 5 could go. So there's 5 different ways you could choose a person for that, right? Is it 5?
It is 5.
Okay, keep that number 5 in here. Now, guys, if one person goes, how many successes do we have then?
5.
One person's going to the dentist in this situation.
Okay.
How many successes is that?
1.
So we would have 0.62 to the what now? 1 times 0.38. If one's going, then how many are failing to go? All right, so somebody run that. 5 times 0.62 to the first times 0.38 to the fourth. Tell me what you have. I'll make sure we agree.
It's okay.
Anybody got a number? Who's running that?
My calculator's stupid.
0.065.
I don't like 0.065. Oh, wait. Say that again.
0.065.
Nah, I don't like that. It should be point. Well, wait. 0.065. Who said 0.065? Man, I don't like that. I'm sorry. I was looking at the wrong information. Man, are you mad at me now? That's okay if you are. Lots of people are mad at me.
I'm angry at you.
Who's mad at you today?
Doesn't matter. I've got my peppermint bark. What did you say again, man? I'm sorry. 0.065? Okay, love it. 0.065. So kids, listen carefully. What's the probability that of those 5 people, knowing that 62% of the people go to the dentist, what's the probability that one of the 5 chosen?
6.5%.
6.5%, right? Anybody have an idea what this is going to look like for 2?
Like a little bit.
Okay, let's try this. Now guys, remember that distribution. It kind of got to the middle, heaved up, and then went down. Let's see what happens here. First of all, how would 2 work, kids? Combination, 5 people. This time, how many are going? 0.62. How many are succeeding at going?
2.
How many are failing at going?
3.
Somebody run that number.
Yeah, I'm with my calculator. If I wanted to do like 5 to the third, so you're going to the 7th power or whatever.
Alright, 2 to the 7th.
Like you say, y to the x, that's 7.
This one should be a little bit over 0.2 something.
That's still not a good.
0.211. Okay, so 0.211, so there's about a 21.1% chance that 21.1% chance that 2 are going. All right, let's do this for 3 people. So what am I going to write for the third person, kids? 0.62 to the, this pen's not working the best. 0.38 to the what? And I'm just going to write the rest down. For 4 to go, that would be 5C4. 0.62 to the what, kids? Times 0.38 to the 1. And then the last one's going to be 5C5. All 5 of them are going. Times 0.62 to the 5th power. Times 0.38 to the 0. Okay, who's got the 1, 5C3 right now? Anybody have that percent for me? 0.344? Love it. 0.344. Okay. Let's see the probability that 4 of them are going. Now guys, if you remember that last distribution, we started low, kind of got high in the middle and went down again. What do you think is going to start happening to our probabilities here after 3 people? Might start going down. Let's check it. I don't know. Well, I'm going to talk about what's going on here in a second. Anybody have the 5C4? should. That'd be awesome. What is it, May? 0.281. Okay. Somebody do the last one for me. Just go 0.62 to the fifth because the other two values are going to be 0. Go 0.62 to the fifth. 0.092.
I think so.
It is, that's what I got.
Okay, now with a little bit of luck, kids.
It should equal 1.
With a little bit of luck, all those decimals should equal what?
If we rounded those, I mean.
We rounded, it might be very close, but let's just check and see. Let me just run them here quickly. 0.008. Plus what next, kids?
0.065.
Plus what?
1.1.
0.281. Okay, we're right there, aren't we? Well, based on some of the rounding, we're right there. Okay. Now, I want you to think about this, kids.
Oh, we're 1/100.
1/1000th over.
Oh,
right?
1,000.
1/1000th over, and that's good. Okay, that's okay. That's acceptable. It's all dependent upon rounding. I want you to think about this, kids. When I said, hey, here's a group of 5 people, and we said, what % of people went to the dentist?
That's not very good.
Is there a better than average chance that they're going or a lower than average chance that person
Better
is
than
going?
average.
Why better than average?
Average is 50.
Okay, so if you go back to this first distribution that I talked about, okay, this first distribution is kind of based on like a 50-50 thing, really. Doesn't talk about percents at all on that previous page. I've got to get there.
Didn't we think average should be above 50? 50 seems pretty good.
Think about this. This is kind of a normal distribution right here. The middle is the highest. But when I start having situations where I say the probability that the person's going to go is 62%, higher than 50%, better than average, either they do or don't go, there's a better chance that they're going to go compared to the chance that they don't go. And when that starts happening, what happens here, kids, is it starts taking this data and it skews it further to the right. Okay? We have more people going, all right? So if I was to go ahead and sketch this, I mean, I'll do my best, but here's what I'm going to have you do with the graph on the page here. It says graph these frequencies. I think that this doesn't show up very well. Did the lines show up kind of decent for you on that?
Yeah.
Can I take a look at someone's notes here real quickly? Okay, so every 2 lines up. Okay, every 2 lines up. I'm going to try and blow this up as best I can, so give me a second. I'm going to condense this a bit.
I'll send you a video we shoot.
Okay. What I want you to do, every 2 lines right here, kids, every 2 lines right here, call this, we'll go 0.10 here. 2 more up, 1. Is my 2 kind of right in here then? So 1, is there another line in here? So right in here is about 0.30. And go all the way up to 0.40, okay? Okay. All right, first row. 0 people were going. I'm sorry, first column, 0 people were going. Second column, 1 person. See, my third column is going to be right about, this did not work very well at all. Third. Oh, I'm sorry, that'd be my second column. Number of people that went was what? 2. And I'm not going to try and, I'll have a 3 here, 4 here. All 5 went. Okay, what was the probability that 0 were going? 0.008. Basically, what value? Almost 0. So I would say, yeah, I'm just going to go right about here for the first one. So the box is very low right there. Maybe right there. Okay. What was the probability that 1 person was going? Point what? 0.065. So that's going to be a little over halfway to 0.10, like so. So maybe right here. Probability that 2 were going. 0.211. Probability that 3 were going. 0.344. Probability that 4 were going. So almost 0.3, right? And the probability that all 5 were going. So almost 0.10. Okay, I have a question, kids. Is that exactly symmetric like the first one that we looked at with the spinner? No. Where is most of the data pushed to then? I know that the center is still the highest bar, but does it seem like there's more higher bars to the right or higher bars to the left of that middle? To the right, which means there's a better than average chance people are going to be going. That's 62%. Now, if that 62% would have been, say, maybe 75%. What if it was 75%?
Oh, I love that number.
Okay, what do you think these bars would do to the right here?
They'd be even closer.
A little bit higher up, and these would be a little bit further down. Okay, see what's going on there? Formula for binomial distributions like this is the combination of how many things you have, how many at a time, times the percentage for the number of
times successes.
Successes to the number of times the probability of
Failures.
to the number of what?
Failures.
Okay. So let's use this information right here to see if we can't answer some of these questions regarding this binomial distribution. It says use that distribution in example 3 to answer the question. What is the most likely outcome of the survey? Well, what do we have as the highest value? 3. We think that of all 5 people, we think the best chance of something happening is going to be 3 people going, okay? 3 people going. This is the most likely outcome, is that 3 people go. That's the most likely outcome. It's the highest bar, okay? What's the probability that more than 3 people surveyed have visited a dentist in the past year? Ooh.
So
More than 3.
we just add those two together.
What 2 together?
4 and 5.
Yeah, this is really, if we're going to know what's the probability that more than 3 goes, that means either 4 went or 5 went. 4 went or 5 went. So really what we do is say what's the probability that 4 go and the probability that, well, what was the probability of 4, kids? 0.281. Whoop. Plus probability that 5 go. 0.092. So what's the probability that more than 4, or I'm sorry, more than 3 go?
0.37.
You guys got it. My main concern, way at the top, do you understand the formula and how it relates to each value? 0, and then a 1, and then a 2, and then a 3, and then a 4, and then a 5. Are you clear on that?
Yes.
Okay. Oh, I think this stuff is so cool. I get all geeked up about stuff like this.
Why?
I don't know. And when I've had lots of coffee, it's even more exciting. Trust me on that. You should try it sometime. It's good. Mike Spencer girls, though. You might need to grow a little more.
I hate coffee.
I don't think I can grow
I cannot drink coffee.
Okay, let me stop this here. Kids,